I've been meaning to go live a little bit earlier, but I was trying to stuff my face with some food, so I waited till I was finished to go live. But yeah, we are live, and I'm just gonna go ahead and get started. I think this is one of the longer sets of lessons, so just to go ahead and get all this ready, or get all this done and behind us. Hopefully, everybody went and got their tests. You have until 2 o'clock, so 15 minutes. If you're watching this and you haven't gotten your test, call the school and start heading that way. Uh, all right. The majority of three phase. So this sounds correct. The majority of three phase transmission circuits in the United States are designed with only three phase transformers connected together to obtain three phase power. And this sounds correct, but it is single phase transformers. Remember that picture from the last lesson? Sorry, it was just a touch of spice, so my nose is running a little bit. I don't have Kleenex in here. Oh well. Uh, yeah, we're good. Yes, so it's single phase transformers to connected together get three phase power. The whole you need to put this over here so my pen is near my who's wants it. All right, so and this will be good. Uh, so a schematic drawing of a transformer looks like this. If you go in your lessons in your homework, you will see. What am I doing? It didn't work. Oh well. All right, and then let us. I probably should have drawn those a little bit further down. Oh well. So what I'm doing right now is drawing a transformer. Ooh, that one was in the wrong spot. Let's see how good I can do with this. Oh, that is. Nah. We'll just freehand it. Fuck it, we'll do it live. This is awful. Oh god. No, I'm not leaving that. Alright. So we have the transformer drawn. Each section. So that's. Each of these is representative of a single phase transformer. You connect three of them together to make a three-phase system. Let's adjust some locations. everything a little bit closer together. Alright. And then let's get everything lined up. Yeah, that looks so much better. Alright, back to the questions. I will come back to this drawing. Today, the majority of dwellings are wired with a 3-wire service. That is a single-phase 3-wire service. So you have 2 hots and a neutral wire that carries the current that is the difference between the two. In the secondary winding of a single-phase transformer, the neutral wire generally carries a current equal to that of either of the 2 outside wires. So an actual single-phase transformer, like what's up on your pole. Let me see. I feel like I had a picture of one. Transformers. What was this? No, that's not it. So let me go into the Blended Learning website. It won't take any time at all to find the picture that I'm looking for, because I kind of know where it is. Transformer connections. Single phase. Let's make that full screen. So here are the primary side, and then on your secondary side you have 2 separate coils that are connected together to give 240. Over here is how a 3-wire service is wired. You have 2 120 volt coils. They are connected together, but also they have a line coming off of them. So if you read from here to here, you are reading just the 120 volts off of this coil. If you read from the hot to the other hot to the neutral, you're reading just the 120 volts from the other coil. If you read hot to hot, you get the 240 volts, which is the 220 volt coils added together. So go back to this question. So this is false because it carries a current equal to that of the difference of the 2 coils. I don't know who that is. Oh, I do know who that is. I will answer that later. Blank refers to the voltage vector relationship of the transformer leads as brought outside of the transformer case. So this is the transformer polarity. Where we at? This is going to be on page 73. We'll describe all of that. Excuse me. Page 73 in your book describes the transformer polarity and what it means and how it is done. 73. So that will be how many degrees out of phase the 2 transformers. So if you took an oscilloscope and looked at your transformer and like hooked it all up and looked at the sine waves, that's what we're talking about here. The methods used to test for polarity and check transformer lead markings do not include. That is the polarization index test. That's not a thing. It won't be found in the book. You can find the AC test, the DC test, and transformer comparison. That will be on page 74. It says polarity test methods, and it's all listed there. A delta connection is a 3-phase connection method that has the wire from the ends of each coil connected end to end to form a closed loop. So, what they're doing in this a delta connection. So I'm going to change my pen to red. I'm going to save into transformers blank. That way I don't have to redraw it every time. Alright, so a delta. We'll write that over here. That's not a pin. A delta connection. A simplified drawing that you will find in your book takes the three. Now this is a drawing, so we have A, B, and C. This is a drawing of just one side. So this is the primary. And let's make secondary green. Alright, so we've got our primary connections and our secondary connections. And whenever we draw something like this, you can kind of see how it's going to go. So what we are going to do is we go A to B, and then that goes up and makes a connection. Then you go B to C, that goes up, skips that wire, and makes a connection. And then you have, so we've gone from coil A and B are connected right here. B and C are connected right here. Then A and C have to be connected. So we're going to go all the way across. Hang on, this is... And then it comes up to there. There are several different ways you can draw this. I will draw a... So they're both going to be delta. We have A, B, and C. We have A, B, and C. And you can just go A like that. Then take B to the same spot as A. That's the same as connecting them together. Then C. I didn't draw the jumps, so forgive me. So A is connected to L1. So A and C are both connected to L1. A and B are connected to L2. And B and C are connected to L3. This is a way, these are two different ways to draw delta. The only difference, the only difference between primary and secondary drawings is that it is flipped over. Alright, in a balanced three-phase delta-connected system, the line current is equal to 1.73 times the current in one of the coils. That is on page 77. The difference between different... so there's two different types of wiring methods for a transformer, a three-phase transformer. There's Y and delta. Delta is what we just talked about. It has current is times 1.73. And Y, it's voltage times 1.73. A way to keep that straight is, so let's new, don't save. So Y and delta. Easy ways to identify the two of them, like if you're just getting told voltages. Delta is going to be 120, 240, or 240, 480, something like that. I don't know if that's actually I think it's just 480. Anyway, you'll have one voltage, and then the higher voltage is just double. Why? Since it's voltage times 1.73, instead of double the voltage, you will have 120, 208, or 277, 480. So whenever you have the weird voltages, like 208 or 277, you ask yourself, why is that so weird? Why do we get the weird voltages? And it's why. So that's how you keep it straight. Y has weird voltages. Y is times 1.7 voltage times 1.73. A Y system is also known as a star system. Go back to my... So delta... If you didn't know this already, delta is a Greek letter that is a triangle. And then down. This is a Y-type transformer. So, easy way to identify between the two of them. A Y, one side of every coil is connected together. And then you have L1, L2, L3. On a delta, two coils is connected to L1, two coils are connected to L2, and two coils are connected to L3. That is an easy way to identify between the two of them. I will show you some pictures in the homework in the other video that I told you about. Go and watch that. A Y to delta connection may be made with 3 single-phase transformers. That's true. And that would be... No. Hang on. Open, blank drawing. Do I want to save changes? Don't save. Okay. Y to delta, you would just wire this one up as a Y. So I'm going to do it real quick. So you've connected all of one side, and then 1, 2, and 3. So that's Y. Delta is stair steps, kinda. So you see how they're wired up. On a Y, one side is connected together, and delta, they are connected to each other. Alright. And those are 3 single-phase transformers. And open delta is without one of these transformers, and it still works. You just have this. So you still get your L1, L2, and L3 connections, but you only have 57% of your capacity. Use your book. With a three-phase bank of single-phase yeah, that's the same question I just talked about. A blank connection may be called a V connection, open delta. Yes, they will all have the same relative polarity to each other. Uh, yeah. So this is in the book. It is on page 94. I can stop using the pen. It's on page 94. There is I think starting on page 93, it starts detailing all of the different transformer connection types, what they mean, how they're used, and that page 94 is where this particular one is found. All right. This is a good chapter. It's got a lot of information that is only, like, all you can do is memorize it. So that's, like, I can explain all of it, and I kind of have, but you can memorize it, and it'll come out a lot, like, better. Whenever you are doing the test, I would open the book. Remember, there's just I want to add one last thing before I let you go. And that would be this picture. I meant to open this up in Paint, but so I don't like it. Let's open it up in Paint. Open with Paint. Resize 500%. All right. So in this picture, you still have your three-phase transformers. So you still have your three single-phase transformers right here. You still have your, and they're still wired, so you can see that this top one is wired in a Y, because one side is all connected together. Then 1, 2, 3. So this is a Y. And then this bottom side is a delta, because this A is connected to C, then B, A and B, and then B and C, and then it's line 1, line 2, line 3. So this is a Y and delta. But in the middle here is the other. So there's two ways a transformer can be wired, and then those two ways can be wired as high voltage or low voltage. So let's say these are all 120 volt, or let's say these are 240. Volt coils. Wiring them like this in series, so the current has to flow through both of the coils, will make it a 480 volt coil. Then down here, if these were 120 volt coils, well, them being wired like they are, so any current would have a way to choose its direction, so which makes it parallel. So these two parallel coils would make this 120 volts, because in parallel, voltage stays the same, and series voltage adds up. So you have high voltage, which makes them in series, and low voltage, which makes them in parallel. That's the only last thing I wanted to say. For more information, go watch that other video. And I will finish this up here. I'm going to start the next quiz. Man, my phone is blowing up. All right. You have a good next couple hours.